Our I can statement for this part of the lesson is, follow along, I can use what I know about geometric figures to solve perimeter and area of complex figures. Now, we've learned a lot about geometric figures like triangles, rectangles, squares, and parallelograms. We know the formulas for the perimeter and the formulas for the area of each of those figures. Today, we're going to use those to solve the perimeter and area of complex figures. Complex, to me, means that it's not simple. There's some extra information there that I need to figure out. Here's an example of a complex figure. Let's take a closer look. If I look at this closely, I notice that it's not a triangle, it's not a rectangle, it's not a parallelogram, it's something different. Let's look at the lengths of each of these sides. So as you can see now, this is definitely not a figure that we have learned how to solve. Well, I know my perimeter formulas always just add all the way around the outside. So that's what I'm going to do. Perimeter equals, and I'll start right here in this corner and move down here, 8 centimeters plus 4 centimeters plus 11 centimeters plus 5 centimeters will get me my total perimeter. And if I do add them all up, I get 28 centimeters. Notice that my label is just centimeters because I'm measuring distance, not area. So the perimeter is very simple. It's just like we've always done. The area, however, is going to be more complex because if this is the base, then I don't know, is 8 the height or is 11 the height? Or if 5 is the base, is there a perpendicular? No, that wouldn't work. So what I really need to think about here is, can I break it into smaller pieces that I know how to solve? And if I look closely here, there it is. I've got a rectangle here, and I've got a triangle right here. Let's first write the equation for the area of the rectangle. If this is the base at the bottom, 4 centimeters, what am I going to multiply it by to find the area of just this section, the rectangle? Well, I see that this line right here is separating it right at 8 centimeters tall. So this line over here would have to be 8 centimeters tall as well. So I've written a bit of information here. I've got 4 centimeters times 8 centimeters. We'll find that area. But I've also written over here for a rectangle, I've got base times height, which in this case is 4 times 8. Next, I have to look at my triangle, and I'm going to zoom in to get a better look. Well, I only see one dimension on it, and it's not the one I need. I need the base and the height. And since I can tell this is a right angle, this is going to be the base, and this will be the height. So I need to figure out what those are. Well, if I zoom back out, I can see that the base right here is the same length as this line down here. So the base must still be 4. So over here on the right side, I've written area of a triangle equals 4 times something, and then I'm going to need to divide by 2 because the formula is base times height divided by 2. So the only thing left to figure out is the height. Well, I don't have a height there, but I do have some other information. I know that this whole thing is 11 centimeters. And I know that this yellow line right here goes up to 8 centimeters. So from here to here must be 8 centimeters. So I'm going to put a little line right here. I say that this is 8 centimeters. And the total length of this line segment, or this side, is 11 centimeters. So whatever is left over must be the height. Well, if this is 8 and the total is 11, I can count up 8, 9, 10, 11. The height must be 3 centimeters. So I'm going to label that on there. Now I can use that information in my equation at the bottom. So down here I've got 4 times 3 divided by 2. I'm also going to write it in my triangle right now. So if I solve for the triangle, 4 times 3 divided by 2, and I solve for the rectangle, 4 times 8, I will get the total number of square centimeters for the area. So I've solved the whole area of a rectangle right here is 32 centimeters squared. And down here in the triangle, I've solved the first part in parentheses is 12 centimeters squared divided by 2 equals 6 centimeters squared. And if I put those together, you can see that I would get 38 centimeters squared for my total area. And there's my final equation. Area equals 32 square centimeters. That's the rectangle. And 6 square centimeters, that's the triangle, will equal a total of 38 centimeters squared. Sometimes you might get a crazy looking one like this, and when that happens, I want to be able to cut it into as simple figures as I can. If I look carefully, I can see that there are some rectangles and some triangles in there that I could solve. But if I look even closer, I can see that it's made up of 2 identical parallelograms. If I look at it like this, I can see that I have a parallelogram with sides of 12 and 5 and a height of 4 centimeters. And if I move this and I look again, it's going to be the exact same thing. So I can solve the area for one parallelogram and then double that to find the total area. So my perimeter would just be adding around the whole figure. So I've got 12 plus 5 plus 5 plus 12 plus 5 plus 5. And I just want to make sure that I have all of the sides represented. So I've got 1, 2, 3, 4, 5, 6 sides, and 1, 2, 3, 4, 5, 6 numbers. For area, however, I'll have to solve it using 2 different figures. The area of a parallelogram is base times height. And I know my base is 12 and my height is 4. But I have 2 of those. I have 2 identical parallelograms, so I'll have to do base times height and then multiply that by 2. So I could say that equals my base of 12 times my height of 4, and then I multiply that whole total by 2. And of course, this would be in centimeters squared or square centimeters, and the perimeter would just be in centimeters because it is distance.